Hello, ladies and gentlemen. Today we're going to be taking a look at surface area of pyramids and cones. So for this, you're going to need your flip chart notes, and we're going to be working on the pyramid and then the cone page. So be ready to flip open to those when the time comes. So let's first talk about pyramids. And if you want to write down just a general piece of information about pyramids, you could do that on the inside of your pyramid page. But we're talking about pyramids being able to have any size or any shape for a base. So square, triangle, hexagon, pentagon, whatever. But the sides of that pyramid coming up to meet at that point, they will always be triangles. You can see that here in this picture. Those sides are triangles. It's called a pyramid because of that. They come together to meet at that point at the top. The base can be whatever it is, a triangle, a hexagon, a square. That's the type of pyramid we say. We have a square pyramid, we have a hexagon pyramid, we have a triangular pyramid, that sort of thing. The most common pyramids that we think of are the ones that have a square base. Okay, that's what you think of when you think about an Egyptian pyramid. That's what you're thinking of. Now, there are different parts to pyramids than there are other shapes. Because they're slanted upwards like they are, there are new labels for us to be thinking about. There's a regular straight up and down height, as you see right here. That's noted with an H. That's located inside the pyramid. That tells me the height of the pyramid. However, there's an L on the edge out here, actually not on the edge, but through the middle of the face. That L is called the slant height. That would be the height of the triangle located on the side of the pyramid. So that's different from just a regular H height given in the pyramid. When we're going to be talking about surface area, we're going to be concerned about what's going on the outside of the pyramid. So those lateral faces, okay, those lateral edges, that lateral area, all of those things that deal with sides, that's what we're going to be looking at. So that L is going to be important to us. So let's think about how we could use the idea of a pyramid to kind of break apart this idea and then obviously calculate the surface area. So stay with me here. Remember, we have that height up and down, and that slant height we're going to call an L goes through the middle of a side like you see here. The H height is for the pyramid. The slant height is for the triangle on the side. So when we tie back to the words we've been talking about, we know the base, we understand edges. Lateral edges are things on the side of the shape. Okay, lateral faces, faces that are on the side of the pyramid. Okay, vertex is that pointy part at the very top of the pyramid. All of these vocabulary words tie back to what we've already talked about. So now let's take a look at how we would actually calculate this. Let's break it apart into those different features that we have. If this is my pyramid, notice that I have a square on the bottom and 4 triangles meeting up at the very top of this pyramid. So if I were to unfold it or do like we did before when we made these solids, this is what he looks like. We have a square on the bottom. We could find this area, and then we'd have a triangle here that has a base and a height. And all of these triangles, because it has a square base, would be the same. So with that in mind, let's try one where we take a look at all the pieces here and find that total surface area. So on your pyramid page, where you wrote down, if you did, some of those ideas about what a pyramid is, let's draw this picture. Take a minute and do that, and then we're going to find that surface area, and you're going to need to show your work for that. So notice on the bottom of your pyramid, you have an 8 given as a base edge. That's telling me that this is a square pyramid down here. It should have in the directions that this is a regular pyramid, but that's what it is. 8, and that means all those edges down there are 8s. So we have a base of a square down here, and that means I need to find the area of the square is 8 by 8. So area of that square would be 64. So that's the base. Now let's talk about the triangles on the sides. So the triangle on the side, I'll have 4 of these guys, and they have a base of 8. You can see that here in the picture. But how tall would those triangles be? If I unfolded them, this would be the height. Add that line right in your picture. Label it with an L. That's the slant height that we need to find right here in order for us to figure out how tall those triangles would be if I unfolded this shape. Now, in order to do that, we're going to have to use the one piece of information we were given about any sort of height, and that's a 12. The 12 is inside the pyramid, however, and we want the height along the lateral side over there, or along the triangle. So for us, we're going to finish or complete a picture in here. We're going to actually draw a right triangle inside the pyramid. Three-dimensional drawing, right? So we're going to draw that pyramid with a triangle on the inside. Think about how long would this piece be down here. That would just be 4, right? Because it's half of 8. And I have a 12 going straight up and down. And I could use the Pythagorean theorem to find this slant height, which would tell me the height of those triangles. So here's my setup. I'd go 12 squared plus 4 squared would be the slant height squared. And now if I go to my calculator and I type in 12 squared plus 4 squared, that's 144 plus 16, that's 160. And I take the square root of 160 to get the L alone. So my slant height would be 12.6. So when I go and I want to find the height of my triangle here, that is 12.6 if I were to unfold this. That's what that slant height tells me. So can I find the area of one triangle on the side? Sure. What's the base of the triangle? 8. What's the height of the triangle? 12.6. So base times height divided by 2 is the area formula for a triangle. So we'll take that 12.6 times 8, and then we'll divide it by 2, and we get an area of 50.6. That's the area of one triangle. So now how are we going to figure out the area of all 4 triangles? Well, we just multiply that by 4 because there are 4 triangles on the sides. So I'll keep that answer in my calculator, just multiply it by 4. The area of my triangles are 202.4-ish for the area of my triangles. But don't forget, I have that base of 64 in here. So I have to add that in, so it turns into 266.4 square units. Square units. So that's how I would go ahead and calculate the total surface area of a pyramid. Notice we have one base and we have the triangles on the sides, and we just take and total those up whenever we want to find that total surface area. Okay, so now let's take another look here as we go on and we look at cones. So the cone, you may want to turn to the cone page and jot a little definition down about that. The cone is a circular base, and the curve meets at a point at the top. So he looks a little like this if you were to draw a picture. You have a height again on the inside, a slant height on the edge like that, and an R for a radius. So just like the pyramid, all those same vocabulary words come in. We have a base. The lateral surface would be around the sides. The height is straight up and down on the inside, but we have a slant height that we'll be using to find that surface area. That's the slant along the edge there of our cone. So if I were going to dissect a cone or take him apart, I can see that there'd be a circle base. But then there'd be this weird piece of a circle, a sector, if you will, that we'd need to find the area of. And because that sector doesn't have a certain number of degrees given, in fact, for each cone it's a little different, basically you would have to do quite the calculations here to find the area of those each and every time. And because of that, people have developed a formula for cones, just like they have for other shapes. After you do the process enough, you start to develop a formula. And the formula for cone is most likely what we'll be working with most of the time. So into your notes, we are going to write the formula for the surface area of a right cone. So next to where you drew this beautiful picture, you would want to write this surface area formula. So it's S equals surface area equals pi r squared plus pi RL. And you can see the pi r squared accounts for the area of the base because that's area of a circle formula. And the pi RL accounts for that weird sector piece that would be around the lateral edge, or around the lateral face there, around the side of the cone. So that would be the formula we use to calculate that. So how can we use this formula then to find the surface area of a cone. Here's a picture for an example that you should get in your notes on that cone page. We're going to find the surface area of this cone. So here's our picture. You've drawn it into your notes. Let's go ahead and write that formula. Surface area equals pi r squared plus pi rl. Do you have a radius? Yes, so we can plug that into our formula. The radius is 5. How about that L? I'm to the L part. I don't have that yet. The L is this slant right here. And in order to calculate him, I'm going to have to do that Pythagorean theorem again. So 5 squared plus 12 squared equals L squared, because the L is on the hypotenuse. Leg squared plus leg squared equals hypotenuse squared. And we have 25 plus 144, that's 169, equals L squared. Square root both sides. The L would be 13. So the slant height here is 13. So I'll plug that 13 in here where that L is, and then we can go ahead and finish our calculation here. Many times you can just type this in your calculator all in one step, but in case you don't have a calculator that does that, I will type in pi times 25, or 5 squared. I get 78.5. And then I have pi times 5 times 13, and I get 204.2, and if I add those two numbers together like it says, my total surface area is 282.7. So I'd say 282.7 centimeters squared for my total surface area. Okay, so that's how we find that surface area of that cone. We're going to use the formula most of the time, so I want to thank you for writing that in your notes, and then we'll go ahead and continue to practice on these in days to come. Thank you for taking good notes.